Yes. Okay. And in this specific section, in the section number 4, we will talk about smart energy control strategies. Okay. So in this, what we will be doing is we will talk about the load balancing strategies, but how? So we will be utilizing the IoT devices. Okay, one, and the combination with the IoT devices, we'll use the AI driven adaptive control system. So here we are trying to blend the IoT devices as well as the AI. Okay, so based on these two, we will be able to get the calculate the demand side energy management system and the peak load control, and how we can able to do the automation in terms of lighting, HVAC. And this is not the high voltage, the alternate current. It is all about the ventilation and like air conditioning. Okay, so which will be mainly implemented in the high rise building and the commercial buildings, right? For that, and also for the appliance control systems. So how this is all about the automation and how we can able to achieve the energy uh, savings and the energy efficiency when we implement the smart the control system, right? And this is all about the fourth section. And coming to the fifth section, this section we'll talk about the renewable energy integration and the optimization. Okay, so this topic, yes, we had a little bit covered in the last module, that is module number 3. In the module number 3, we spoke about the types of renewable resources, right? The solar, the wind, and also a few other, the hydro and the few other renewable resources. And we try to integrate with then smart grid technology, right? So that we can able to pool the resources which are generated in the different energy generation systems, correct? And here we in the same way, what we will be focusing is we will be focusing on the IoT based solar, and also the and also the wind power. So this is how we can able to achieve the integration and optimize based on the IoT. Okay, and also again, as per your syllabus, again we have to talk about the AI algorithm. Okay, that is the similar algorithm I will not be teaching again. So because the all three, the algorithms what we which is already discussed, it will be covered. Okay, and the same AI technologies will be implemented in this. Okay, that will be used for the energy forecasting, energy storage management, and so on. This is all about the section number 5. And the section number 6, this is the case study. And if you see closely, this is smart grid automation using IoT, AI based energy this is all generic one. Okay, and so um, it will be an complete here we will be doing the hands on. Okay, we will build again one project from the scratch, and you will be able to understand how we can able to implement the AI models for the IoT and the AI energy management system. Again, here also I will be utilizing the AWS account, and this will be mainly focused on the AI models, implementing the AI models. Okay, because as per your syllabus, there is a lot of sections where we need to study more on the AI. Correct. So for that reason, AWS. So now, what is the special about this module number 5, right? Module number sorry, module number 4. So I will be introducing the new technologies apart from the AWS. Okay, AWS will be the core technology. Apart from that, the KNX and also other three. And these two will be a major focus for this section. Okay, and yes, apart from that, everything else it is in generic one, so I will be covering it, no issues. Okay, I believe this uh, the syllabus is fine, and any doubts, let me know. Okay, so let me go back to the PPT. Yeah. So today's session, like it will be just an introduction. Okay, just give me a minute. Yes. Okay. Great. Okay. Yes. Let me. Okay. So now we'll start with an IoT, and we'll talk about what exactly the IoT is, and how what is the architecture, and so on. Okay. So coming to the IoT, so what exactly the IoT is? So you might have heard about IoT in the lot of in the technologies or in the news, or if you are thinking about following any latest technologies, right? And IoT is the most talked term, that is Internet of Things. Correct. So in everybody home, we will be having some smart devices. Correct. Smart devices. So these devices will be connecting to the internet. Correct. And so it could be an simple example, like it could be an smart lights, and it could be an Alexa. It could be an uh, it could be like small devices which can able to control from your laptop or else your mobile from wherever in the world you can able to do it, right? That is the technologies which is called as IoT. And yes, the devices should need to be very much smart to connect to the internet, and it should be able to take our command to do the certain operations. Okay. So the IoT offers an transformative solution for the connecting the physical devices to the digital world. So this is all about the IoT. So we will be having the physical device, correct? As I was mentioning, some lamp or else some smart devices, which is in the terms of physical device. Physical device. So what we are trying to do is we are trying to connect that to the digital world. Okay. So this is the definition of the IoT. So basically, we are trying to transform the solution to connect the physical devices to the digital world. Okay. So what are the benefits? Like IoT technologies are keep on evolving every day, right? So we are just focusing on the energy management here, right? So it's not only limited to the energy management. We can extend it to the different use cases also. But yes, we will be focusing on the energy management. In the energy management, now we'll focus on the real-time monitoring. Okay, one thing. And how we can able to do the real time monitoring, it's all about the data driven, right? We will be trying to collect the data from the various devices which will be implementing in the field, and then we will be taking some decisions, so data driven decisions, and we can able to do the automation to increase the efficiency. And by increasing the efficiency, obviously we are reducing the cost, correct? And also the carbon footprints. So this is little bit introduction about the IoT. Okay, now let's talk about little broader spectrum. So before we dive into the basic architecture of the IoT, let's talk about what exactly we will be achieving in this section. Okay. So here, as I mentioned earlier, so it is all about the energy management. Correct. So energy management, as I said before, it is the monitoring and the controlling, and also we are trying to conserve the energy in the building. Especially we will be talking about the building, because most of the cases it will be the building part. And the second one is So the field devices, field, it could be in substation, right? And also it could be an the open organization, or else like any of the system. So open system, I can say open system, right? So but mainly we will be focusing on the high rise buildings and the big establishments, so that the because the IoT are most probably implemented in the last or else vast the quantity in the buildings, right? So we'll be focusing on that. Okay. And also in the open system, like open areas, like we will be having the home, we will be having the smart meters, right? Okay, yeah, this is one of the case. Now again, just to give an once again what exactly the IoT is, right? So IoT is all about we are trying to blend the sensors with the software, and when we blend these two, we can able to exchange the data, exchange the data. So we the data we can able to utilize to process in the cloud. Okay, it is similar to the the SCADA system, right? There it is complete system, but here it will be focusing mainly on the IoT devices. Okay, this is one thing. And this is, and yes, as I said, it will be on the internet. And how we can able to monitor this? So there is one little the management tool we are having, that is called as so IoT for energy management. Okay, so this is the one of the concept, or else you can able to say this is the software which we will be utilizing to use it in the IoT, uh, this complete architecture. So this piece of software, what it will be doing is it will help us to configure the complete stack. It will help us to do the the troubleshooting, and we can able to have the visibility in terms of the design stack. Okay, across all the complete stack. It could be in sensor, the software, and the data exchange, even the AI analytics specifically. Okay, we will be having the visibility when we will be using the energy the IoT for the energy management tool. Okay, this is what we'll be focusing on. And once we implement this, what we can able to achieve is, one is the proactive measurements. So previous to this, in the legacy design, it is all about reactive, correct? In the it is all about reactive, that is, if something breaks only, we will get to know what exactly the problem is, and we have to do the troubleshooting, and either we have to replace the complete system or the specific component in the system, and we will be doing the troubleshooting, correct? So that was the reactive approach, right? So now let's jump into this is all about the introduction. Now let's slowly move towards the architecture part. Okay, so now let's start with the basic architecture, and let's see the stack, and then we'll deep dive into the complete one by one stack. Okay, now before going into the architecture part, I want to just give you the glimpse. So whenever we are designing an IoT the system, right, what are three main the factors we need to consider, we need to keep it in mind, right? One is the scalability, that is the scale. So if you see the IoT, these are the devices which are exponentially expanding. Now we can say we have the billions of devices which is interconnected, and these devices are sending the messages in the regular interval of time, because they need to communicate either with each other or else to the main controller. Correct? The scalability. And whenever we design a system, we need to always keep in the mind about the scalability. Okay. Now, the second one is the precision. The precision is very much important because all the sensors, as I was talking, we have the billions of sensors which is there, correct? So every devices needs to connect and talk to each other. So there needs to be an precise the coordination, correct? So when we able to achieve this, we can able to achieve the grid reliability and also the billing accuracy and the protective and also the protective relays, correct? The precision is very much important when we design an IoT system. If we don't have the precision, then there will be no synchronization between the devices and also between the device and the any of the AI analytical tool, or else here if you see this billing software, correct? So it cannot be able to achieve. That is one thing. And the third important the factor we need to consider is like determination. So this is all about the physical actuators. Okay. So for example, if we are planning the IoTs in the in the substation, which is having the circuit breakers, and also if you are planning any of the smart home, correct, there will be having the smart meters, smart inverters. In that case, these devices should be able to get the input from the IoT devices or the command which we will be giving to the IoT devices, right? So they should be able to get the command and should be able to take the uh, and it should be able to do the actions what is needed. So whenever we design a system, so these are all the three main the factors we need to consider. Okay, that is one thing. So this is one. And the coming to the architecture part, so this is very much critical. Probably if in the examination you might get an question telling that like, can you able to explain the architecture of complete IoT stacks, right? So this is what it is. And yeah, so coming to this, yes. Okay, so this stack, whenever we design or like the when it comes to the architecture, okay, so we are having the file layer. If you see, we have the file layers here. This is one first layer, and the second layer, third, fourth, and fifth layer. Okay, and it is, you might feel like this is similar to the SCADA system, right? So it is almost similar to the SCADA system. And this the SCADA system, it will be aggregating all the device information to a single point. Then this will be that will be sent to the cloud or a central monitoring station, correct? But now there is only small difference here is all the devices will be able to communicate to the layer number 5, that is application layer. It is like so independently all IoT device can able to communicate. That is the key difference here. In the SCADA system, the all devices, the field devices may not be able to connect to the fifth layer or is like application or business layer, correct? We could not be able to talk to each other. So this is in smart devices, right? So that is the key difference. Now coming to this the first layer, that is the first layer is called as device layer. Okay, as the name suggests, the layer will be having the sensors, actuators, and the controllers. So these are all the physical devices which will be on the field or else in the building. And then so for example, so these the controllers can also be called as local edge. Okay, local edge node. So what this local edge node, this is the technical term, you need to remember this. So what this local edge node will be doing is, so this will keep on monitoring the parameters. For example, it will be monitoring the energy, okay, and voltage, current, the power. This is the electrical parameters. So these devices, the IoT devices are not limited to the electrical parameters, right? So this can able to also measure the air quality. It can able to also measure the temperature, right? And this can able to manage the occupancy. And also apart from this, it can also be extended to the valves. That is, this is specifically in terms of the the walls, that is the water walls will be there, right? So in the big buildings, if you see, there will be an bigger walls, and which is an motorized operated walls, correct? So this is, we can able to monitor, and we can able to operate by using the IoT devices, by taking the information and sending the information to that specific IoT devices to take the necessary action, correct? So this is one of the wall, and also the pump, and also other meters. Okay, so if you see these devices, correct, this is not only limited to the, especially on the IoT device I'm talking about, this is not only limited to the electrical parameters, that is voltage, current, and the power, and also add the frequency. Okay, this is not only limited to this, it is extended to the other parameters, right? HVACs, and this is also the other one. So this is the key difference, and you need to be very much familiar with this. Okay, where exactly and what is the use case in terms of IoT devices on the device layer. Okay, let me erase this. Now that was the first layer. So we got to know that this IoT devices is not only to the electrical, but it is expanded to the other services also, right? Now, so when so we have the IoT devices. Now it has to be connected to the network, correct? So that whatever the parameters which we have gained, that needs to be transferred to the business layer, that is, which is in the fifth layer, correct? How we will be doing is, we need to have that one connection, that is, we call it as in the transport layer, or we also call it as a network layer. So in this the network layer, what we'll be having is, if you are familiar with the terms called network switch, network router, okay, and if the IoTs can able to connect through the Wi-Fi also, okay, Wi-Fi, or else we can able to do the complete physical connectivity, that is by using RJ45, the cable. Okay, this is a twisted pair cable. Okay, and so these devices which will be connecting to the this router, or else it can be connected to the switches. Okay, let me draw a neat diagram for your understanding. Okay, let me close this. Okay, let me redraw this. So think like this is an IoT device. Okay, so this is an IoT device 1 and IoT device 2. So these two will be connecting to the one. physical switch. So this is called as a network switch. So this will come with an different ports. When I say ports, it is on physical ports, 24 port, 48 ports, and so on. And also this is, hold on. Yeah. Yes. So this is okay. And the good part about this switches is like there will be again, this is number of ports, and there will be other type, that is the data. Also there is other term called PoE. Okay, this is called power over Ethernet. Whenever we are designing in the smart devices, right? So we need to have this network switch which is capable of having the PoE. So PoE stands for the power over Ethernet. Whenever you connect a device, usually in the traditional system, how it will be like, so we needs to have one, we needs to have, if you, this is the device, we needs to have the power cable, correct? So power line to the device, this is device. And if we want to take out the information, then we need to have the communication line, right? Communication line. So here we need to have to lay the two cables. One is for the power line and other one is the communication level. And again there is a problem. We cannot able to club these two because of the problem, that is electromagnetic interference, right? So when you club the power line with the communication line, there is always a problem of the EMI, because and also when there is an EMI, we will not get the precised the data what we are expecting from the communication line. So this is one of the problem. So how do we resolve this in the real bird scenario? What we are doing is, so we will be utilizing the PoE, right? Let me erase this. So you just try to know more about these network switches, because if you are designing a system in the real world, right, this is what any of the architect or the design person needs to know. If you are planning in complete smart devices, then how do you do that? So you need to know how we can able to connect that. So what we will be doing is we will be selecting some PoE. This is the power over Ethernet. This power over Ethernet will be connecting directly from the port to the device. These are all the IoT device, correct? So we don't need in this Ethernet cable. This is called as Ethernet cable. Okay, this will have the both the power as well as the data. We don't need to lay the power cable separately. That is the biggest advantage of this. And also we can able to deliver the power, and we don't need any separate socket, that is the single phase or three phase socket we need to deliver the power, correct? So that is not needed. Only the single cable, that is Ethernet cable, which can able to deliver the data as well as power. And the good part about this is like for the IoT devices, probably it might need 15 watt, or else the higher the models, it may need 30 watt or 45 watt. Okay, as per the ISO standards, we can able to select the switches which can able to deliver the 15 watt, that is called PoE. The UPoE, that is the ultra PoE that can able to deliver the more than 30 watt, nearly 30 watt, right? So this is how the smart IoT architecture will be. Okay, so this is the key important device in complete network when we design an IoT system, right? So here we are eliminating the need of the socket, the power socket, I mean. Okay, only this network switch we can able to utilize as a power delivery system for the IoT devices, and the same switches can be utilized for the data also, correct? And similarly, if we have the multiple the areas, let's say this is an area 1, this is an area number 2, and this is an area number 3, correct? So in the similar fashion where we are designed the area number 3, we can able to utilize 3 separate network switch, which is an PoE enabled. You need to be make sure that this is PoE enabled. Okay, and this the ports needs to be capable of sending the power to the IoT devices. Okay, so these IoT devices can be able to connect to the different field devices I was mentioning earlier, right? It is not only limited to the electrical, but this IoT complete architecture is extended to the other the mechanical systems also, right? So we can able to have the HVAC, right? It is like think like a dampers, and we can able to have the what is a variable frequency drive, VFDs. This is very much the critical component in the HVAC. So the variable frequency drives, this is very much implemented in HVAC systems, and this is driven in the PLC based controlling system, and that is connected to the IoT. So the IoT sensors, for example, I was mentioning earlier, right, the temperature and also the air quality. So these IoT sensors that is can able to sense the temperature and air quality. Those information will be fed to the variable frequency drive. Okay, this frequency drive, what it will be doing is it will change the speed of the motors and increase the air quality, air circulation, so that based on the requirement, the air quality or the temperature, there will be an adjustment in the parameters, correct? So yes, VFD plays a very much key important role in especially in the high rise building or the HVAC design. Okay, and yes, when we implement these kind of systems, that is the sensors, we can able to achieve the automation train. So this is one of the system. Okay, and the same switch, this is network switch, which is having the PoE, we can able to utilize for the other systems. For example, if we have the pump, correct, the induction pumps, or else like these pumps will be used in the bigger industrial where there is a need of the fluid circulation, correct? So these pumps needs to be and dynamic one. So there should not be a manual intervention. So based on the required parameter, these pumps needs to be started or needs to be it should be able to adopt for the required conditions, correct? How do we do that? Again, the pump will have the IoT devices. So where IoT devices will be implemented, this will be implemented in the walls, correct? So in the walls, these IoT devices will sense the flow and the temperature. Again, if we are measuring any temperature, then after this, so these parameters will be fed to the pump, and so the pump will be sending the data back to the switch. And yes, the pump will never be powered by the switch, so switch will not have that much the capability. For this power, we need to provide from the external feeder. Okay, that is one thing. So if the devices is more than 30 watt, okay, and also 50 watt, 45 watt, right, we cannot able to power through the network PoE based switches. We need to have the separate feeder for these. For example, the pump may need very much higher power, correct? So for that, the feeder, the power line will be separate. Power line will be separate. Usually it will be in three phase. The cabling from the power feeder, this feeder will have separate, but data will be, again, it has to be through the switch only. Okay, let me erase this. Right, so this is how the architecture of the IoT in the real world scenario, how it looks like. Okay, now again, so this is not only limited to the single the area. Okay, so this is for the area number one, and similar way we can able to extend up to the area number two also, right? And now we can able to combine area number one, two, as well as three, and we can able to take all the details back to the single, the gateway. So think like this is a router. Okay, so and from the router I will explain the further process. Okay, this is from the router we'll take the data. Okay, I believe up to this part, up to transport layer, the network layer, everything is clear. So let me know if you have any questions. Okay. Okay. Yeah. So these two were the very much critical part. Okay. And the example what I was giving, right, it is an actual scenario. That is how the system design will happen in terms of networking, correct? So we covered the device layer and we have covered the transport layer, correct? Okay. So I think we'll take in 5 minutes bio break. Okay, I will be back in a minute. We'll be back at 8. Okay, just take in bio break. ಕೆಲಸ ಮಾಡಿಸ್ಕೊಂತಿದ್ಯಲ್ಲ ನೀನ್ ನನ್ನ ಹತ್ರ. ಏನ್ ಮಾಡಿಸ್ಕೊಂಬಿಟ್ಟು ಸವಾಸಕ್ಕೆ ಬರಲ್ಲ. ಸ್ಟಾಪ್ ಮಾಡಿ. ಈಕೋ ಸ್ಟಾಪ್. ಈಕೋ ಸ್ಟಾಪ್. ಅಲೆಕ್ಸಾ ಸ್ಟಾಪ್. ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬೇಕು ಮಾಡು. Okay, so we'll continue from where we left. Okay, fine. I think. Okay. Okay, so we spoke about the device layer and the networking layer, correct? Echo, stop. So we'll touch base on one of the important topic in the network layer, right? So I was mentioning how we can able to utilize the IoT and how the IoT devices can able to connect through the internet. Now the question will be how these the devices can able to connect to the internet. So there should be certain the address needs to be embedded in that network design, correct? How do we do that? So you probably heard about this part. There is the IP addresses, correct? Let me write here. Yeah, so every device will have the IP address, internet protocol address, correct? So usually um, so I will do one thing. Let me open the new page. Just give me a minute, guys. So I will just open the new window so that I will just create one new. Yeah. Now let me share my screen. Okay, so I wanted to draw something. Yeah, I think yes. Okay, so here, just a minute. Yeah, now let me take a pen. Yeah, so just think like this. The device, we have the IoT, we have this one is the area number one, let it be area number one, and this is area number two. This is IoT, this is our devices. Okay, so again, let's take an IoT number two. So now, as I was mentioning earlier, so we need to select one network switch. Okay, again, so these network switch will be connecting to the devices, correct, over the PoE. Let's consider this as an 15 watt. Even this is as an 15 watt, and let's consider this as an 40 watt. Okay, this as an the 15 watt. Okay, and let's consider this switch as a 1 and this switch number as a 2. Okay, now, so as I was mentioning, this is an this specific cable can able to carry both the power as well as data. Okay, we don't need to provide in separate the cable for the power. Okay, now, so let's see how these devices can able to communicate. So every device will have the IP address. Okay, so there will be two kinds, the public IP address and the private IP address, correct. So now, so inside, for example, this you think like an a router, and this router will be connecting to the internet. Okay, and inside this there will be an aggregation switch. This is aggregation switch, network switch, aggregation network switch. Okay, and this will be connecting to this field switches, distribution network switch. Okay, now these IoT devices, okay, needs to have the IP address. As I was telling previously, we will be having the private IP and the public IP. In the private IP, so let's say it will be starting, if you might have heard or listened about this one. So this private and public IP will be an 8 octet, correct? This one, two, three, four. Okay, I mean the 4 octet, and everything will be an 2 to the power of this one. Okay, so everything will be an increment of the 2 to the power 2. So this is how we can able to calculate the address. So usually the private IP address will start have the range. We call it as a cider range, right? So this is one of the range. Other one is 172.16.0.0. Okay, this is one of the range, and the other one is 192.168.0.0 and /16. This is a mask. Okay, don't worry about this. Just focus on this. Okay, and probably if you are inside any of the office network, right? So if you open any laptop, you will find the IP addresses. Okay, and so why I'm mentioning this is like every IoT devices will have to have the private IP address. Either it could be an the 10.10.0.0.1, or we can able to have the 192.168.0.1, something like that. Okay, this is the address which needs to be there for the this inside the network IoT devices. Now let's say from here So internet, we will be having only the one public IP that will be provided by the internet provider. Okay, the public IP, it could be different range. Okay, so this is routable IP address. Why I'm mentioning here is, like for example, if the IoT inside one of the area needs to be communicated to the other one, right? It has to go to the internet. Then internet will have the routable IP address, and it will come back to the specific area number two, correct, through the internet. So for that reason, we need to have the both public IP and the private IP, and the private IPs are non-routable. That is, we cannot reach these specific IoT devices from the internet because it will be having the non-routable IP, that is private IPs that will be within our network. So there will be only one public IP assigned to any of the specific organization, or else like the building or like any specific area. So in this specific router, there will be an network address translation will happen. Okay, that is what we call it as. So the private IP address will be converted to the public IP address, and then the packet will be moving to the different destination. Okay, so this is how actually the architecture will work. So this is a little bit in depth. You don't worry about it, but try to understand the concept, how actual design will happen. Okay, yeah. So that is all about the IP protocols, and this is not only limited to the IP address. Okay, we have the different protocols. For now, we'll not go in the depth. Let's understand to communicate with each other to different devices. We need to have the IP address. Okay, and again before, like after router, there will be an the firewall, so that firewall will block the malicious attacks. Okay, that is all about the network layer, correct. Now let's talk about the processing layer. Okay, if you see, we have the name called edge, correct. So in that, so we'll be having the gateway and the local compute interlocks. So the gateway, let's say for example, you want to process the complete the information what you have received in the network layer. Okay, so instead of you going back to the internet or into to the cloud, so before that you need to have the processing inside the location of the perimeter, correct. You will be having the server, and in the server we will be processing these IoT device data. Okay, so how do we do that? So as I was mentioning, we'll be having the routers, correct. So think like this is a router, and from the router we'll be going to the internet. So before going to the internet, so we'll be processing the same data locally again in the server. So in the server it will be an the software running whatever desired output we need, or else the command which needs to be sent to the other IoT devices, correct, from without going to the internet or the cloud. Let's say, let's connect this to the AWS cloud. Okay, this is in cloud integration. Instead of we going from the perimeter to the internet and then to the cloud, from the cloud back to the perimeter, instead of that, what we can able to do is we can able to do the edge computing. That is the processing layer. From here inside the edge, inside the perimeter, we can able to compute the required the data, and we can able to send the command to the device layers. That is called as edge computing. Okay, so edge computing, again by definitions, we are trying to compute in the edge, that is in the perimeter level, not in the cloud, that is called as the cloud. And let's say we have a different and yeah, so if you say like you don't want to compute in the edge, we can able to send that data to the cloud. It could be an AWS, it could be an the Azure or GCP and so on, or else different cloud provider also. But now so we need to have the gateway. So gateway will be sending the data, that is one thing. And yeah, so that is, and here in the gateway we can able to filter the unnecessary data. We can able to do that. Aggregate if you have the multiple IoT devices, which I was mentioning earlier, correct? So we can able to aggregate. When I say aggregation, so collecting of the data from the different sources, making as a single source of data, that is aggregating all the data, making a single source and sending the data, so that we can able to reduce the bandwidth, and also we can able to improve the efficiency. This is what the processing layer will be doing it. Okay. That is one thing. So just to summarize, in the edge we can able to do the computing, we can able to process the data which we have received from the IoT devices, right? And also we can able to do the filtering, and also we can able to do the aggregation locally. That is all about the processing layer, right? Now coming to the cloud injection, let me erase this. Okay. Now, coming to the cloud injection, as per your syllabus, specifically they have mentioned it is we need to learn about the cloud injections, right? And also the storage part. So let's say we have the gateway, and the IoT device. So that will be reaching out to the gateway. From the gateway, we'll be reaching out to the cloud. And here we will how we are able to do it based on the protocols, that is most popular is MQTT, right? So we will be utilizing this protocol, and also it will be over the HTTPS tunnel, or secure connection, correct? And so the brokers are nothing but the publisher and the subscriber model. So that is the MQTT, and these data will be stored in the database. So usually we will store it in then time series database, so that why, because the IoT will be having the timestamps, so it will be generating the continuous the data in the regular time intervals, right? So for that reason, so preferably we will be storing those datas in the time series database. Okay. And that will be processed. Yeah, so this is all about the cloud ingestion and the storage part. And from this, the next is a critical one, that is all about the analytics. So what do you do? What you will do with the data which we have acquired from the IoT devices? So we need to have some insights, correct? So how do we do that? Once we have the data in the cloud, so we'll be running the ML model. So we'll be looking in the depth what exactly, how many the the famous ML model we are having, and what are uh, the key differences by using the different ML models. So we'll be looking in the further sessions. Okay. So before that, for this architecture review, so we'll be utilizing the ML model. What ML model will be doing is these models will inject, or else this will be taking the details from the IoT devices, and then it will be processing. Then we can able to create the dashboard. Okay. So it could be in reports. It could be in business related dashboards for the decision making. Okay, and it could be in billing. It could be an other the integration. From this we can able to integrate the other systems also, right? Okay, and this is how the complete architecture look likes. So the business owner can able to look into the dashboard and take the necessary actions. Okay, so this is how actual the architecture looks. And let's say like if you get a question telling that to explain the architecture of the IoT, right? So this is how you need to define different layers, right? 5 layers. So let me know if you have any questions on this architecture part. Okay. Yeah, let's move to the next. Okay. So we got to know about the architecture, right? We know we have the different 5 layers of the architecture. Now let's deep dive into the individual layer. So in the first, the bottom layer, we had the devices, correct? The different devices. So these devices, let's say in this specific slide, we can able to see we are trying to get the information of the PV cells, correct? So in the PV cells, there could be an different the parameters like how much the power has been generated, what is the DC current, and if we need to convert that to the AC, correct? So how the conversion, what is the harmonics, and so on. So these are all the parameters we are trying to collect it, right? So for that, what we need to have is we need to have the smart meters. Smart meters is nothing but it could be an IoT device. It is called as an IoT device because this will be connecting to the internet, and from the remote locations or the remote area, we can able to operate these devices without the manual intervention. Correct. So now, so how do we get this data? So these are all the smart meters, that is the IoT devices. These will be able to convert the analog analog what the parameters which I mentioned earlier, right? The power, the voltage. If we are utilizing any other sources like we have the wind power, right? In the wind power we can able to monitor the wind speed, what is the frequency of the generation, the harmonics, and so and so in that case also the same, the device will be implemented, and these devices will be able to convert the analog to the digital. Okay, and then these parameters will be sent to the server or else the cloud, let's say server or cloud, for the further processing. So for that what we'll be doing is, so we can able to utilize this specific either it could be a modbus or else IEC 61850, which we already saw in the module number 3, right? So I will not be discussing again here. So we'll talk about the new the protocols like there are different protocols I will be explaining, not this, because you already know what exactly the modbus is and the other IEC 61850. So these are all the protocols which we already discussed, and these are all the protocols which will be utilized to send the data from the smart meters to the server or else like the controller. So this is what the controller, right? And yes, the if you see, the timing is everything, because the timing, the accuracy, the sample rates needs to be very much precise, Why? Because like if we don't get the data at an accurate time, so the action will not be taken at a specific and accurate time, right? Everything needs to be precised. How do we do that? So for that, there is the concept called NTP server, right? So you might have heard about NTP server, configuration of NTP servers. So what this specific server will be doing is, so this servers will be helping it to synchronize the time in the all the devices. Okay, so you go anywhere in the world and you try to configure any of the IoT devices or the smart automation in the building, correct? So first thing you need to do is you have to sync all the devices, IoT devices, with the NTP server. Okay, so what it will be doing is it will help us to sync completely, even the controller and the devices. It will be on a single time, so that the syncing will happen properly and there will be no the errors in the synchronization, correct? It could be also the PTP, and also the IEEE standard is 1588. Okay, so this is how we can able to connect the devices on premises to the controller, and based on this the protocols. Okay, okay, I think yeah. So coming to the actuators, so this also called as an effectors. So we call it as an effectors also because this is very much critical physical device which will be in the network. I mean in the complete the smart automation network, correct? So this is the uh, key breaker which will take the final action, that is to make or the break the circuit, right? So this the actuators, it is it could be an the switch breakers, and it could be an controlling the inverters, where we use the battery system to store the energy, correct? For that, and also it could be the transformer tap changers also, right? Transformer tap changes. So even this is very much critical because based on the change of the position of the tap in the transformer, the output can be varied, correct? So this is in terms of the electrical, and so this IoT is not only limited to the electric devices which I mentioned earlier, right? So let's see how this actuators will work on the mechanical devices, correct? Okay, so when it comes to the mechanical devices, we have HVAC dampers. So these are all the dampers, so which controls the airflow within an building, and these dampers, the increasing or else decreasing of the airflow and also the temperature, it can be command by using single software. Okay, so these dampers are IoT devices which will be measuring the temperature and also the airflow. Okay, this is one thing, and the second thing is the battery charge and discharge. So again, this is one of the use cases where if we have the larger scale of the battery farm, where we need to monitor very closely in terms of the charging of the batteries and the discharging of the batteries, and what rate the discharging of the batteries are happening, right? So this is how this is one of the use case. Okay, right? And again, I said earlier, right? It could be extended to the uh, the motors also, right? Okay, so we covered the tap changes, the battery charges, and the discharge control. Now, this is in terms of the field devices. Now, when it comes to the controllers, okay, these are all the brain. as I said earlier, we can able to process these the data which we have received in from the on premises, either in the edge or else in the cloud. Correct. So you can able to invest on the edge, then fine, we can able to have the the server which will be processing the software, and also we can able to use the controllers, these controllers, right? What is these controllers? So these controllers could be the PLCs means the program logic controllers, or else we can able to use the RTUs, remote terminal units, or else embedded the processor. What this will be doing is, so these controllers will aggregate again. If we have the multiple IoT the farms, then these controllers will aggregate. That is, it will collect the data, and this will be having the different ports. If you see, these are all the ports, and these are all the connectors. Okay. Now what this will be doing is, this will run few logics. The based on the logics, even the PLC can be used to give the output signals to the specific IoT devices for to take the necessary action, either to the close or open the circuit breakers, or open the dampers, increase or decrease the lights, and so on, right? So this is where like we can able to do the edge computing. Okay, this is one thing. And yeah, again, the PID loops, the droops, and DERMS, distributed energy resource management sources. This is one of the use case where we will be utilizing these PLCs or the controllers with the logic for the data processing. Okay, that is one thing. Let me, yeah. Okay, let's talk about the protocols now. Just to talk about the protocols, in the last the module, in the module number 3, we spoke about the Modbus, correct? When we were talking about the SCADA systems, we were talking about the Modbus, and even we spoke about DNP3, where we are trying to get the fault detection system in the electrical, especially on the electrical system, right? And also we spoke about the IEC 61850. So even in the IoT design, we can able to utilize these protocols in the field. Now we will be having the two more the protocols, that is long range WAN. LORAN means the long range wide area network. Okay, and we will be going in depth in terms of the packet and how the long range wide area network works. So we will be having the separate session on this, because this is one of the key the protocols we need to study, correct? And also the Wi-Fi, as you know, it is a short distance, the wireless communication from the device to the controllers, right? So these what do you say, the protocols will be used to connect the field IoT devices especially. Okay, or else the building, inside the building, it could be in building also, right? And most of the IoT and the automation is happening within the high-rise buildings, most of the cases, right? You should be able to understand what protocol needs to be used when you design the complete automation within the building. Okay, now, so these will be aggregated, and now to process further, we use MQTT and COAP, HTTPS, or like it's an WebSocket, correct? So these are also the very key important protocols. Okay, so once we have the details in the gateway by using these protocols. By using these protocols, further processing to the cloud, we can use these three important protocols, which is specifically mentioned in your syllabus. Okay, and I will be having the separate session on the MQTT, COAP, and the HTTP, and this is very much critical. The HTTP, if you know the HTTP and the WebSocket configurations, right? So it will help you to understand how actually the building automation will work. Okay, this is about the bridging. Okay, now, yeah. So again, so just a glimpse. Okay, I will just give you a very high level in this introduction class about the MQTT, and I will be going in the depth, especially on these the protocols. Okay, now let's just on very high level. Let's see what exactly the MQTT is. So MQTT is a broker. Okay, so it is all about then pub sub model. Okay, so the pub sub model, it is very much famous terms when we will be designing in complete architecture, IoT and the building automation system, correct? So how do we do that? So one of the most popular the protocol is MQTT, where we might be having the different devices, correct? You might see here, it could be an battery, it could be an meters, and it could be an the wireless devices. So basically these devices needs to be smart enough to understand the protocol and get it subscribed to this specific broker, correct? So what this is an lightweight binary farming. Okay, so you need to be very much familiar with this is an lightweight binary farming, and the small header, it will have the small header. Don't worry, I will show the packets, then you will understand what exactly I'm talking about. Okay, for this introduction you just try to understand what exactly the MQTT is. Okay, and the good part is this will be having the persistent session. So the meaning of persistent session is the session will never get lost. Okay, it will be up and running. Okay, that is the specialty of this MQTT. It will be having the persistent session. And other part is like the QS one, we can see quality of the service. This is called quality of service. So we have different quality of service level like 0, 1, and 2. Okay, so the more the quality of service, very much higher the quality what we get in terms of this MQTT. Okay, and so the more the QoS, the better, because if we have the unreliable network or else less bandwidth network, so these QoS will make sure that the data which we are getting from the IoT devices, correct, from these devices, will reach out to the s- server. Okay, so to make sure that we use TCP, not the UDP. So I will explain in the further coming session what exactly the TCP is and UDP. Okay, so the TCP is reliable one and UDP is faster but not that much reliable one. Okay, so this is one thing, and yeah, so we can in this specific MQTT, what we can able to retain the last the state. So we can able to this specific MQTT protocol will have the last state about the IoT. We can able to use that for the further processes. Okay, and if you see here, it is always rely on the TCP. Okay, and also ACL is an access control list. Okay, for now, don't worry. This is an the privileged access will be given to the devices in the network, correct? For that. Okay, and this is how the publisher will work. So it will register the device, and then the broker will try to push that data to the subscriber. So subscriber could be on premises. Usually it will not be an on premises, just to take an option. It could be an on premises. Most of the cases it is on the cloud, AWS, Azure, or GCP, or extract, or other cloud. Okay, so it will be in continuous the journey. So where IoT device will generate the data, the broker will push the data to the subscribers. Okay, this is called as publisher and the subscriber model. Okay, so probably in the exam, if you are being asked to explain the MQTT little bit about the architecture, right? So you need to define these terms: the publishers, the subscribers, the brokers, and the QoS, the quality of service, and the TCP, and so on. Okay, yeah. Now again, so other two, the protocols. Now, so in your syllabus, the first one is MQTT, and second one is COAP and the HTTP. And again, so we will go in the depth in the coming session. Okay, try to understand what these are like. So these protocols are like defined in the RFC. So if you want to learn more about these specific protocols, right, you can able to download this file which is available in the internet. You just have to type the RFC 7252, then you will get the complete information about this specific the protocol. Okay, so COAP is constrained application protocol. Okay, this is constrained application the protocol. So what is it? It is based on the UDP, the faster, but it is not reliable. As I said before, we in the transport layer we have the TCP and the UDP, correct? So the even though the UDP is faster, it is not reliable. But TCP, it is not that much faster compared to the UDP, but it is reliable, because if the packet is missed in the specific transportation, the UDP will never try to get that again, but the TCP will do that. Okay, that is one. And the RESTful API, it is designed on the RESTful APIs. Okay, and also again, the API are application programming interface. This is where we can able to get the data from one system to the other system. Okay, and coming to the strengths, it is very lightweight. So the payload on the packet, it will be very much lesser, the lightweight one, and it will support the multicast. Okay, and also it can able to map to the HTTP semantics. This is one of the strength. And coming to the use cases, so let's say you will be having very much smaller bandwidth, correct? It could be in your network, it could be an like a 50 MB connection, and also like you could be able to, you cannot able to offer the much higher power, correct? So in that case also, this is the specific protocol which we need to have it. Okay, yeah. And coming to the HTTP, and this is based on the TCP which I was mentioning. It is an reliable one. Again, this is the request and response. And the good part about the TCP is, for example, you might have unknowingly worked on the TCP, right? So when you open any web browser, so everything will work on the hypertext transport protocol. This is called HTTP, right? So usually when you open in a browser, you might see some lock, correct? So this is telling that this specific page is using hypertext transport protocol, the secured one. Okay, in the similar fashion, what we are trying to do is we are trying to implement the same protocol in the IoT and the building management systems. Okay, this is one thing. And also this can be utilized in CDN. CDN is a content delivery network. You don't worry about this. This is not relevant, but you should be knowing where exactly these are utilized. Okay, and coming to the ideal use cases. So let's say like you have very much bigger data needs to be transferred at a secure manner. Okay, and so we cannot use the this constrained application protocol. So constrained application protocol is very lightweight, which it is not capable of taking the larger payload, right? In that scenario, the HTTP is where comes into the picture because it can able to take the larger the payload. Okay, that is where we have the specific bulk downloads, the device which stacks. Okay, this is the very high level about this, and let me, okay, let's talk about little bit differences. Okay, yeah. So before going to the differences, like I want to give you very high level about telemetry data. So initially I was mentioning the building automation system, PMS, or else IoT. So these will be having the billions of millions of devices, correct? So there will be a lot of devices connected, and these devices will generate the data. So think like we are using the Modbus, okay, for the field device, okay, and these the field devices will generate the telemetry data. So we cannot use the complete every telemetry data, correct? So this has to be filtered out. So we what we will be using is we will filter and aggregate. Okay, so if we are trying to utilize all the data which is generated from the device, it will be in too much of data, and the bandwidth required is very much higher. For that reason, what we will be doing is we will be trying to filter out, reduce the telemetry volume. Okay, so that is the key difference. So how we can able to do is we are utilizing the edge processing. So combination of the edge processing, we are trying to isolate the noise and enforce the safety, right? So what we are doing is from the edge processing we are trying to filter and aggregate, and also local analytics. As I was mentioning earlier, we can able to do the local analytics running locally if it is in smaller the models. Okay, and if we don't have any uh, the internet connectivity, and then after that we will be sending that to the cloud. Okay, okay. So now coming to the other layer, the cloud, correct? So this is pretty much straightforward. So in the cloud infrastructure, how the connection will happen from the on-premises to cloud. That is, first level is ingestion. So we need to take the data and dump into the cloud, correct? One is the message brokers, So we will be utilizing the AWS IoT core or the TLS, right? That is one thing. And then we will be routing that. So we will be using the streaming processes. We are processing that in the Lambda, which is the serverless, and the Kinesis or the event hub. We will not be using this. So we'll be focusing on the Lambda and Kinesis only for the data. And coming to the storage part. So yes, we will be storing every data in the time series for the telemetry and the long-term storages for the forensic analysis. Okay. After this storing the data, we are trying to do the modeling for the analytics. So in this four step, first it will be an ingestion, then routing and processing, then we need to store the process data, and then we need to apply the logics. Okay. Yeah. So coming to the life cycle. So how the complete infrastructure will work is like we need to provision. So it is all about the zero touch. So when I say that zero touch, it is an industrial standard term what we use. It is called as zero touch because the configuration of the any of the IoT devices and the field devices, correct? It is done with a very secured manner. Okay. So by using certificates and the SAS, the secure access token, right? So based on these, we will be doing the provisioning, and then we will do it will be connecting, and we will be managing, enforcing the desired state by using the device twins and the module configurations, right? And then we will be updating those models, I mean the firmwares, by over the air. So this is, you don't worry about it. This is just in the basic understanding how the complete life cycle will happen. Okay. Yeah. And coming to the strategies, again, we will be having the two strategies, right? So we can able to have the different channel for the higher frequency, that is like the phaser, like real time data, routing the short retention, like high frequency tier, so which need immediate control and anomaly detection, right? So we need to have the different the channel for that. One is for the high frequency and other one is a low frequency, where we have the slow telemetry and the trend matrices, right? So this is how we need to have the two different the channels. Okay. So what it will help us is, it will help us in the reducing the cloud injection, the number of volume which we need to dump into the cloud, it will be reducing it. Okay. Yeah. So again, this is very much critical. Okay. So what how we can able to secure our complete IoT infrastructure as well as the BMS is, like we need to have this transport layer certificates. Okay. So that we can able to secure our connections. So these connections which will be utilizing the certificate authority certificates, right? That is one thing. And the second part is the least privilege. Okay, we need to create an access control list. This is access control list, that is like which device can able to talk to which device, and who can able to configure or who can able to log into the system or else like devices, those kind of access control list we needs to create one. Okay. And the third part is secure boot. So this is very much critical. So secure boot is where we need to make sure that the device will have the authentic the firmware. Okay. It is not like it has been jailbroken, or it has been infected with the malware and so on. So that is one thing, the secure boot, and that needs to be encrypted by using the cryptographical, so which we already discussed in the last sessions. What are the different techniques of encrypting, right? So we have AEC, AS1, 28, 256, and so on, and other asymmetric and the symmetric, correct? That is one thing. And the last one is automated certificate rotation. So a certificate will have the validity of around probably 13 months, correct? So after this 13 months, we need to change it all or rotate the certificate, right? This is one thing. Yeah, so this we already discussed service level objective, right? I will not go in again. Yeah, so this is the critical one. Okay, so this is a very high level the chart. Okay, so coming to the layers, this is then the IoT reference matrix. Okay, so let's see perception, like the first layer, device layer. The core function is what we'll be having is the layer, first layer. We have the sensors, the actuators, local control loops. And what are the key protocols we'll be using? That is the technology is a Modbus or else IEC and NTP for the timing and so on. What is the design rules? The safety, the criticality, we need to see how exactly we can able to safeguard our devices. The function stays locally, the timing must be precise. So this is what the basic design rule we need to understand. Okay, and coming to the second, that is then transport layer. So this transport layer, the brings the field to the network network layer, correct? It is trying to do the communication. What protocols? MQTT and COAP, HTTP, and this is MQTT is continuous, and the UDP, and this is on the provisioning mode. So when we have to use the MQTT, when we need to have the continuous telemetry data, okay, enforcing the mutual transport layer security one. Okay, this is MQTT is chosen when we need the continuous telemetry enforcement. And coming to the edge layer, it is then gateway aggregation for the safety interlock, and the key protocol is industrial gateway and edge machine learning one. Okay, so the design criteria rule will be filter the noise locally. So we are trying to compute the locally and try to filter out what is not necessary, and only we are taking out the data which is actually needed, correct? That is one thing. And the cloud ingestion, so storage, and we can able to use the pub sub brokers and so on. So this is very much a high level, which is and summarizes the what we actually discussed previously, right? Okay, and so apart from this, so I will be discussing the three important uh, I mean, four important technologies I will be introducing. One is the KNX. Okay, this is very much important if you are looking for an, the good opportunity in the automation, building automation systems and IoT automations, right? So the KNX technology is very much needed. If you learn what exactly the KNX is, how the KNX works, it will give you a very much good knowledge, right? So the KNX is best for whole building infrastructure. Okay, so we'll do one thing. So we'll break for for breakfast, and we'll come back after 15 minutes. And after that, I will start explaining these technology so that you will have the good the feeling about this. Okay, we'll come back after 15 or 20 minutes. Okay, thank you.
ಚಿಚ್ಚಿ ಬರ್ಸು ನಿಲ್ಸ್ಕೊ ಮಾಡ್ತಾರೆ
ನಿಲ್ಸೋದಷ್ಟನಾ
ಏನು ನಿಲ್ಲಿಸ್ಕೊ ಮಾಡ್ತಾನೆ ನಿಲ್ಲಿಸ್ಕೊ ಮಾಡ್ತಾನೆ ನಿಲ್ಲಿಸ್ಕೊಂಡ ತಕ್ಷಣ ಮಾಡ್ತಾರ ಚಿಚ್ಚಿ ಮಾಡು ಬಂಗಾರಿ ಚಿಚ್ಚಿ ಮಾಡು ಬಂಗಾರಿ ಚಿಚ್ಚಿ ಮಾಡು